Hey guys, welcome back. I hope you enjoyed your spring break. I, on a fun personal note, did not enjoy mine on account of I have some type of viral flu like symptoms where I tested negative for flu and strep. But I'm doing pretty good. So if some of my assignments are posted a little bit late, then it's probably because I fell asleep midday due to a fever. But it's a low fever, and I would never let a pandemic stop me from teaching you. So we're good. All right, moving on. I hope that your spring break was not about being infected with a virus or poison ivy. I got that too. It was just a whole slew. And with that, we are going to continue on with our course of online learning. All right, so first thing, a couple of reminders. Number one, so as far as assignments go, we're doing something a little bit different back from break. Our weeks are now going to be A, B, A, B, and then Friday is going to be basically just help day. You can schedule a Google Hangout. I will have a setup link for that I will probably post a video of how that works before Friday. But Friday is going to allow us to kind of communicate, hold video conferences, hold classes if we need to sort of go over the material and anything you guys might be struggling with as we continue on with our quarantine. Okay. Other things, I will still be holding office hours every day between 1 and 2:30. During that time, you're welcome to send me an invite to a Google Hangout. Sometimes that looks like a chat room or a text messaging kind of center. It can also look like a video call or else a phone call where we can't see each other's faces, just hear each other. Whatever you guys want to do is perfectly okay with me, or you can just email me, or you can also comment on your assignments. In fact, I would encourage you to do that because most of the time I receive a lot of emails about the same sorts of questions about how assignments work or if they're able to open. So if you go ahead and comment for the whole class, then you're probably asking something that someone's already wanted to know. All right, with that, if you have certain circumstances that prevent you from completing an assignment, I want to work with you guys as much as possible, but I have to know what those circumstances are, or at least some information about them. So if your internet is currently out, if you are sharing a computer, if you are consistently going to your part-time job, which is now basically a full-time job, or else babysitting a large number of younger siblings or nephews, nieces too, whatever, then I would like to know about that, if only so that I can extend your guys' deadlines and give you as much help as quickly as possible, okay? So the key to this is going to be communication. This is an important life lesson, but also especially during a pandemic. All right, moving right along. The Friday before spring break, I have now finished grading your guys' wave tests. If you were not able to take the tests, then your grade has tanked. You should do that. I will open this test back up if you have not taken it on Friday. I will open it all day on Friday to all classes. If you have already taken the test, do not retake it. It is not for you. That is done. More information coming about retests. I'm going to talk to Mr. Pacell about what both the energy goal retests and also possibly the waves retests will look like. All right. So with that, let's go ahead and dive on into today's assignment. So day 3, the duality of light. This has got a couple of things. So number 1, instructions are here, but I also put them in the PowerPoint. The attendance kind of assignment for today is filling out this exit ticket, this Google form. This is how I count that you are here. If you have a limited access, just go ahead and do that. Also, if you're interested, especially if you're sharing a computer, you can download Google Classroom in the App Store. And while it might be difficult to fill out some of these larger assignments, doing things like exit tickets, watching like little videos, or any kind of short assignments sort of allow you to do that on your phone. And considering what class looked like before break. I'm pretty sure most of you have a phone. All right, other thing, rubric is right here. We'll go over that in just a second. Okay, let's go ahead and start, and I will drag this guy over. Okay. We are now starting our second part of our waves unit, which is on light. So this is going to go over light, color, optics, and the applications of light. This should take us about a week and a half. After that, we get to spend around a week on gravity and gravitational pull fields. After that, we start electricity and electrostatics, and we may or may not have like a week left of thermodynamics, but it's looking unlikely. So we're getting closer, guys. Full steam ahead. Also, rumor squashing. For you seniors, I think you're still going the full time. This is not just like ended for you all of a sudden. All right, today's assignment. So again, it's posted on Google Classroom and also right here. Listen to this video. This is the video that you are listening to right now. Fill out this Google form. Again, available for you on Google Classroom, but also if you click it. So it's your name. It's a few questions, all of which you should be able to do just like around your house without a whole lot of information. A couple questions about the unit, and then something about your spring break. I'd like to know how your guys' lives are going. And then finally, complete the CER. And I had some quotes because light, the unit, really lends itself to more quotes. All right, so what is light anyway? See, now you can see the whole thing. Light is the visible part of the electromagnetic spectrum, which ranges from radio waves to gamma rays. All electromagnetic waves are just fluctuations of electric and magnetic fields, and they transport energy. Sometimes you see it written as they are energy, but since energy isn't matter, it's just conveyed through matter, and that's not necessarily the case. Light isn't really any different from any other type of electromagnetic radiation. You're just fortunate enough that this is the type that you get to see. Other animals, other organisms can see other variations of the electromagnetic spectrum, or perhaps smaller versions of the electromagnetic spectrums. For example, your dog, if you have one, is red-green colorblind, so they're missing some of those wavelengths. In fact, if we look at what you can see right now, the only thing that you can see is light. So objects either do two things. They either emit light, which means that they're able to generate light themselves. So for instance, the sun. The sun is going to be the source of most of our light. But we have a few other sources too, generated artificially. Or they're going to be things that reflect light. So objects either emit or they reflect. If they reflect light, then what happens is they typically absorb some frequencies of visible light, and then they reflect other frequencies. The ones that they reflect are usually the colors you perceive that object to be. So again, if we think about this in celestial bodies, then the sun emits light, the moon reflects light. It has no light of its own. Electromagnetic waves look something like this, but not really, which is a fun thing about this unit that we're going to get into. All right, here's a video. I'm probably not going to watch it with you, but it's pretty good about what is light, a few quick definitions, a quick reminder about the speed of light and why it exists that way, and then also how our eyes have evolved. We're going to talk a lot more about eyeballs in general, but just some quick tidbits. Okay, this is the electromagnetic spectrum. This is not new. Down here we have all of the visible light ranging from violet, blue, green, yellow, orange, and red. Perfectly summed up with Roy G. Biv, which is the acronym that we use to remember all of the types of light that we can see. However, again, this is just a tiny, tiny portion of the spectrum, all of which act the same way, You just can't see these things. But that doesn't mean that they don't exist or that other things cannot perceive them. Let's see. You have higher frequencies and shorter wavelengths this way, longer wavelengths, shorter frequencies this way. Sorry, sometimes it's late. Quick reminder, all of these things, regardless of the wavelength or the frequencies of which they emit or are absorbed by, are traveling at the same speed in a vacuum. That speed is 3.0 times 10 to the 8th meters per second. Okay? That's the same. Yeah. Early concepts of light, what people used to think. So if we look at early Greek philosophers, they thought that vision resulted from basically streamers emitted by your eyes making contact with an object. So it wasn't that objects gave off light or that other objects gave off light. It was that your eyes had an inerrant quality in order to see things. And they kind of visualized this maybe like laser beams just emitting from people's eyes. I think it's Euclid had an interesting story about how this is why if you drop something really, really small on the floor, he used a needle as an example, but I always think of like earring backs. I lose them in carpets just all the time. So if you've ever lost something tiny on the floor, Euclid said that the reason you can't see it from up high is because your eye is not close enough that there was enough light in order to see the object, that your eye being close to the object was the thing which gave it a vision in the first place. Okay? This was, of course, wrong. Like, really, really wrong. Light is one of those weird topics where we thought it was one thing, and then they decided it was something else. And now we teach it like it's both of those things, but in actuality, it's not really either of those things, which is kind of just, like a good description of physics, basically. Like, Newton came up with an idea. Some other people came up and they said, well, Newton, that's not quite right. And then Einstein said, you're all wrong. I did all the math. Here you go. And then now we say, well, even Einstein, didn't have it all figured out. So this is just the best we got. Okay, so a couple quick things. I'm not going to go into the history of this because that is for your assignment. But know this. So Newton thought light was a particle, which he called a corpuscle, which is a fun word to say. And he kind of thought of it as like a thing, like a packet of energy. Then he performed some experiments with prisms. It's pretty cool. Christian Huygens, and Robert Hooke thought light was a wave. Fun story if you're looking just for something to do in your endless amounts of spare time that I know you guys have now. Robert Hooke and Newton have a huge scientific rivalry. They used to call out each other in scientific papers, and they would publish them in the newspaper, and it was impressively petty, and I would definitely recommend just look into it. It's super interesting. Okay. And then Albert Einstein came out with the photoelectric effect, which showed a little bit about how light is both a wave and a particle, that both of these things could possibly be true. But he sort of edited it back and said, first off, Einstein was really against using the word particle. And he didn't actually coin the word photon either. More about that later. But his photoelectric effect was still the best we have to explain how light could possibly be both. And now we just refer to light as both a wave and a particle because these are the types of things in the world that we are most experienced with observing. And therefore, they're the best models that we have to explain the world around us. So this kind of brings us back into how science is shaped by the experiences that we as humans have and what we can experience with our senses and what we can measure with things that we can experience with our senses. Anything sort of outside that realm is just, it's not necessarily what it is, but it's just close enough, if that makes sense. It would be like if I went to some random planet and I saw an alien life form, then I would probably try to equate that to whatever animal I thought it looked the most like on Earth. So that's not really what it is. It's just the best way I have to explain that. So light is light, and electromagnetic waves are just electromagnetic waves. And we're going to describe them using terms like particle and wave because that's sort of the best we got. And with that, not that yet. We're going to move on to today's assignment. All right, so this is a CER, otherwise known as a claim evidence reasoning. You each have a copy of this in the assignment. So directions, please use the CER. Please answer in complete sentences. That means a noun, a verb. I think, honestly, that's probably a part of speech. I don't know the part of speech. Okay, I'm sorry. All right, the claim is already there for you. Evidence and reasoning. There are 4 checkboxes for each thing. You should check into these. So make sure your evidence is relevant, is linked, doesn't lack an explanation or reasoning, and isn't specific enough. Finally, your reasoning. I can't tell you that this is probably the biggest sort of thing that students have like a hard time with, is reasoning. It seems like everyone's really, really good at stating their evidence, but their reasoning is just because that makes sense. And that's sort of circular reasoning. So make sure you don't fall into that trap. Make sure you're justifying. How does your evidence support your claim? How does what you said here support this idea? All right, experiments to mention. There are 4 of them. Newton's, just mainly his just ideas, his prisms. This isn't like an actual experiment per se. The Huygens-Fresnel theory, otherwise, if you just Google Huygens theory of diffraction, that works too. There's Young's double slit experiment, and then finally Einstein's photoelectric effect. Terms to use include array, corpuscle, reflect, interference, diffract, polarization. And actually, since I'm checking for those, I would recommend if you wanted to maybe just underline those guys whenever you use them in your paragraphs. That would be super excellent. Next, a series of resources. You don't have to use these. If you use your own resources, then I would like you to cite them down here, okay? So go ahead and type another thing if you use resources other than these. However, all of these experiments can range from the very simple explanations to the calculus-based explanations. So the resources I picked out for you guys are tailored for our level of understanding right now. I would recommend using them. Be careful supplementing them. So there's one summary video right here. It's 3 minutes. It's a really, really good explanation of what you're about to learn. Okay, I would definitely recommend looking into it. There's one on Newton, one on Huygens, 2 on Thomas Young, 1 with Einstein. A summary with videos is a link to basically an online textbook for high school. And then finally, if you're really, really curious what the actual light isn't really either of these things explanation is, then it's a pretty good summary in this Wired thing. But as you can see, they eventually get into the calculus version stuff. So I wouldn't recommend it unless you're just really, really curious. All right, so what you guys are gonna do. Number 1, light acts as a particle. What is the evidence for that using these experiments, these terms? And then reasoning. Why does that make sense? Why does the fact that light behaved a certain way in Newton's prisms support the idea that light is a particle? What does that mean? Okay. Claim 2, light acts as a wave. Again, your evidence here, your support or your reasoning for that evidence here. This shouldn't be anywhere from 1 page to 1.5 pages. So what I'd like you guys to do is write one paragraph for each. That means, and actually let's go ahead and put that in there. One paragraph for each evidence and reasoning. 3 to 5 sentences. Thank you. Okay, and then yeah, that's your assignment for the day. All right, let's also go here real quick, and I just want to show you guys this. So here is our rubric for how I'm going to be grading you. So that little check sheet, the rubric here. Hold on, sorry. Got two screens up and it's a little weird. All right, this rubric, make sure you're using this. Your claim you don't have to worry about. I already gave you both claims. We're supporting both things. That's okay. But your evidence, these are what's going to be these are what I'm going to be checking off as we go. So in order to get a 10, you have all the things check marked off. Used all the terms and all the experiments. Again, you don't have to underline those. It just makes it easy for me to pick them out. Grammar and formatting are perfect. A quick note about that. I'm not going to dock you guys points if you do not use the Oxford comma correctly, or if your clauses are not backed up like they should be. However, if it's something that spell check could catch and you just left it red, then that's on you. They literally have a button now. They didn't have a button back in the old days. They fixed these things for you. You can also get Grammarly for free. Underlines things. It catches emails and it tells you if your tone's okay, for crying out loud. So it takes 2 seconds to press the button. If you're failing to do that, then you don't have a grammar issue. You're just lazy. Fix it. Thank you. This isn't to be confused with if you're just using the wrong forms of there and to. I mean, you should check those. That's, work on improving it a little bit, but that's not the same thing. Okay? As far as formatting goes, single space, no Comic Sans. I don't know, 11 to 12.5. Other than that, no one really cares. All right, 9 and 8 look pretty similar. Basically, as you go down, you just have more check marks within your evidence and reasoning that you're missing one of those, or you failed to use all of the terms or experiments as backup. They all are in there for a reason. And then grammar and formatting, again, just unless you're just completely failing to press the spell check button, you're probably good. And then finally, make sure you're using complete sentences, right? 0 for not attempted. And then that's your assignment. And here is your exit ticket, which you can complete before that. Try to do. Because I am posting this so late, sorry about that. I'm going to blame all the Dayquil. The due date has been a little pushed back. So normally, oh, sorry, I need to fix this. Oh, okay, wait, that's why. Normally, this would be due on Tuesday at 8 a.m., but I went ahead and made it due Tuesday at midnight because I'm late getting it to you guys. Again, I apologize about that. Please let me know if you have any issues completing the assignment. If you're completely lost, then I can try to redirect you to some more videos. Or if you're having some kind of tech complications. Again, I can't help if I don't know what the issue is. So I hope you guys are having a great back to school time and hopefully, staying indoors. Wash your hands. Don't go to Walmart, and especially don't pick up the packet of chicken that the lady copped into when she forgot to chicken wing her arm. Not that I'm saying from experience. All right. Let me know if you have any questions. Bye.